Today we are distinguishing a metabolic emergency, galactosemia, from a digestive inconvenience, lactose intolerance. First, understand the normal physiology. So, milk contains lactose, and this lactose is breakdown into glucose and galactose by lactase enzyme, and both of these enter into the liver cells. We have two different location and two different problems. Zone A, that is inside the cell. Here galactosemia happens here, so it's a metabolic problem. While in zone 2, the gut lumen, where digestion problem is there, so lactose intolerance happens here. Galactosemia, the trap. Galactose enters the cell but cannot be processed because GALT is deficient. This GALT causes conversion of galactose 1 phosphate to glucose 1 phosphate. So the toxic metabolite get piled up. The main villain is galactose 1 phosphate and the sidekick is galactitol. Galactose 1 phosphate causes liver and kidney damage, while galactitol causes cataract and brain damage. So the cell is poisoning itself from the inside. Why galactosemia is a medical emergency? It causes cataract. So here we have peculiar wild drop cataract. It causes hepatomegaly and jaundice. There is risk of sepsis, especially of E. coli. This question is frequently asked. There is renal damage leading to Fanconi syndrome. There is brain damage causing lethargy and delay. So all this makes this condition a life-threatening. When the symptom of galactosemia occur, so it usually start after very first feed. So symptoms usually appear within 3 to 7 days of life. So look at the ticking clock 3, 4, 5, 6 and 7. The symptom appear here. One line to remember. So galactose enters inside the cell but cannot exit. So become toxic. Now let us understand the pathophysiology of lactose intolerance. In lactose intolerance, no doorman, that is lactose is missing. So lactose remain inside the gut. So it never enter into the cell. No cellular toxicity occurred, no organ damage. Now look at the bacteria party. So lactose inside the gut lumen act as a osmotic agent. So it draws water and inside gut the bacteria cause fermentation of lactose to lactic acid, gas and small fatty acids. Now as a result of bacteria party, the digestive distress occurs. So there is flatulence, there is bloating, there is watery diarrhea. But catchy point, no liver damage, no brain damage, no cataract. If we look at presentation of lactose intolerance, the neonate is usually fine here. Symptoms occur in children, older children and adolescent. So it can happen after gastroenteritis. The one liner to remember, lactose stays out, lactose never enters the cell, so leading to diarrhea. Now the basic comparison, galactosemia GALT deficient and it's a medical emergency where liver failure and sepsis can occur. While in lactose intolerance there is lactase enzyme deficiency, it's a digestive problem leading to bloating and gas formation. So one is metabolic problem, other is digestive problem. With the help of urine and stool sample, we can have bedside differentiation between these two conditions. Now look at the urine sample in galactosemia. So glucose dipstick is negating because dipstick finds only glucose, while Benedict test is positive because Benedict's test positive for galactose. In galactosemia, galactose in the blood, it spills into the urine and cause positive for reducing substances. Now look at the stool sample in case of lactose intolerance. Lactose are not absorbed, they are fermented in the gut, causes stool to be acidic and sugary. So stool for reduced substance is positive and stool pH is less than 5.5 due to bacterial fermentation. Urine is boringly normal, that is negative in case of lactose intolerance. Both these conditions are exactly opposite. Urine for reducing substance are positive in galactosemia, while stool for reducing substance are positive in lactose. Now 5-second memory trick. Galactosemia pees sugar, while lactose intolerance poops sugar. Hope you enjoyed this video. Kindly like, subscribe and share. So this is a fantastic way to learn